Hi grade 7s, welcome back to another video lesson. Today we'll be doing problem solving for 7.1 to 7.3. So before you continue watching, what I want you to do is I want you to go to page 360 of your textbook or page 23 of the PDF of chapter 7, and I want you to complete all the questions. There are 8 questions in total, 1, 2, 3, 4, 5, 6, 7, 8. So please do all the 8 questions first to the best of your ability. Show all your working out, and then do them first before you continue watching. After you finish, watch the video and mark your own work. So if you haven't done the work already, please pause the video now. Now I assume that you should have finished. If you haven't finished, pause the video and please do all the questions first, and then you can continue watching and mark your own work. So what I want you to do is to make sure you mark your own work, check whether you got your questions correct. If you got them wrong, then change it up, make your own corrections based on the video if you don't understand. So first question. A weather update on the news lasts 1/15 of an hour. How many minutes does the update last? There are 60 minutes in 1 hour. So there are 60 minutes. Let me do this in black color. So there are 1 hour. 1 hour equals 60 minutes. And so all we have to do is do 60 multiplied by 1/15, and so 15 goes into 64 times exactly, so that's just exactly 4. That is equal to 4 minutes. So the weather update lasts 4 minutes. That's it. And remember to answer the question, how many minutes does the update last? The update lasts 4 minutes. Don't just write the number down. You have to answer the question appropriately according to the question. So that was question 1. Now, question 2. You usually run about 5 miles every day. Today you run 1/4 of the usual distance. Write a numeric expression that could be used to find the distance you ran today. So all we have to do in part A is to write down what it actually means. So it's 5 miles every day, but today you only ran 1/4. So today you ran 5 miles times the 1/4 that you ran, and so that will be equal to 5/4, and then turn that into a mixed number that will be 1 1/4 mile. Of course, that's part 2. That's part A. It's just write it down. And then in part B, we evaluate. That's equal to 5 times 1 at the top. So that's equal to 5/4, which is equal to 1 1/4 mile. And then interpret the results. So you write down, today you ran 1 1/4 mile. Then in part C, it takes you about 2 1/15 hour to run 1 mile. So if 1 mile equals 2/15 of an hour, if we ran 2 miles, all we have to do is multiply that by 2. If we ran 3 miles, we multiply it by 3. And today we ran 1 1/4 mile, which means that for 1 1/4 mile, we have to do 1 1/4 multiplied by 2/15. And so for this one, what we have to do is we have to multiply. We have to change 1 1/4 back into a improper fraction. So that's equal to 5/4 multiplied by 2/15. 15 and 5 both have common factors, so I can divide top and bottom by 5. This becomes 1. This becomes 3. Once you divide it by 5. 2 and 4 also can simplify. So if you divide 2 by 2, that becomes 1. Divide 4 by 2, that becomes 2. So now we have 1/2 times 1/3, which is equal to 1/9 of an hour. And so let's finish up the question. 1/9. So ran, how many minutes? So this is an hour. That's 1/4 of a mile. That's 1/9 of an hour. Then in order to change that back into minutes, 1/9 times 60, 60 divided by 9, or you can divide top and bottom by 9. Or let's divide it by 3 first. So we have divided by 3, that's 3 at the bottom. 60 divided by 3 is 20. So we have 20 over 3. So that's 20 over 3 minutes. And then that is the same in terms of mixed numbers. We have to convert it into mixed numbers. 3 goes into 26 times, that's 18. And there's 2 remainders. So that's going to be 6 2/3 minutes. And so let's answer the question in full. It took 6 2/3 minutes to run 1 1/4 mile. So that's question 2. Question 3, describe a situation that can be modeled by the expression of half times 3/4. So it can be anything. I'm just going to make one up. So let's say a bag of candies, half, I'm going to type this out so that it's easier for you to see. Whoops. Question 3, half the candies in a bag are square shaped, and then we also have square shaped, and let's say half the candies in a bag are green in color, and what else? Half the candies in the bag are square shaped or triangle shaped. So it's either half is square, half is triangle. Hopefully you get what I mean. And then half the candies in the bag are green in color, green, or let's say it's blue or red in color. So either green or either red. Half of them are red, half of them are green. And then the other one, let's say 3/4 of the candies are let's say that they are 3/4 are small in size, and the other quarter would be large. And so this expression will be the fraction of candies that are green, that are square, green, and small is half times 3/4. So that's just a situation. So hopefully you understand what that means. This is open-ended, so just make up any other, any sort of situation that can describe half times 3/4. So moving on to question 4 now. You burn 450 calories per hour when biking, and you biked 3/4 hour on Friday, half hours on Saturday, and 3 1/4 hours on Sunday. So the question asks you, how many calories did you burn altogether on those days? So first of all, we're going to add up all the fractions. So we're adding it up first. So we're going to do 3/4 plus 1 1/2 plus 3 1/4. And if you remember our lesson from previous chapter on adding, what we have to do is we have to turn them all into the same base, and then whole number plus whole number, which means the only one which needs to change will be this over here. That becomes 2/4. So that's 1 and 2/4. Then this will be no whole number plus 1 plus 3. That's going to be 4. And we have, let me just show the working out. So that's 1 plus 3 as the whole part. And then the fraction part, we have 3/4 plus 2/4 plus 1/4. Add them all together. That will be 1 plus 3 is 4. And then 3/4 plus 2, that's 5. 5 plus 1, that's 6/4. So 4 and 6/4, which is the same as 3/2, which is the same as 1.5. So this is the same as, let's simplify. That's 3/2. And so 3/2 is 1.5. So that is the same. Our overall answer should be 5.5, because that 1 would move on to the next whole number. So that's equal to 5.5. And then what we have to do now is we have to find out how many calories that is. So we biked 5.5 hours, and we can burn 450 calories when biking. So first of all, this is the total biking time. Total biking time. And then the total calories burned. So total calories burned will be 5.5 multiplied by 450 calories per hour. So when we multiply, we have to change that into a mixed number. So that will be 11/2 multiplied by 450. And so 450 divided by 2, they can both be divided. That's going to be 225. And so we have to work out what 225 times 11 is. So at the side, you can do your working out. 225 times 11 will give you 225 over here. And then we have 225 over here. Sorry, 225. And then add them up. 5, 7, 4, 2. That's 2,475 calories. And so the total calories burned is 2,475. Question 5. Write a rule that describes the product of a non-zero whole number and a fraction is greater, and a fraction, when the product of a non-zero whole number and a fraction is greater than the whole number, and when it is less than the whole number. Now I know this is a little bit confusing what it means, but as an example, I will give you, let's say 3 times 1.5, that's a fraction that is greater than a whole number, would be equal to, let's change to 4 instead. 4 times 1.5 will give you 6, where 6 is greater than 4. And then I'm going to give you another example. 4 times half is equal to 2, and so 4 is greater than 2 this time. Now what I want us to notice is that this fraction is bigger than 1, and so the result will be the result will be bigger than the whole number. And then if the fraction is less than 1, then the result will be less than the whole number. So hopefully you understand what that meant. Now to put this in writing, you can put it here. If the product, if the fraction is bigger than 1, the product will be greater than the original number. But if the fraction is smaller than 1, the product will be smaller than the original number. And hopefully that makes sense to you. Hopefully that makes sense to you. So for this example over here, the first one, the product is bigger than 1. So here, whoops. This, let me annotate that here, is bigger than 1. And so the result will be bigger than original number 4 over here. And then our fraction for this one, half, is smaller than 1. And so the result, 2, will be smaller than original number 4 over here. So hopefully that makes sense. And that applies to all fractions. It applies to all fractions. Good. Now moving on to question 6. You work at a scrapbook supply store. There are 18 inches of space on the shelf for a display of new scrapbooks and cardstock packets. Each scrapbook is 1 1/4 inch wide, and each packet is 7/8 inch wide. Write an expression for the amount of space needed for 11 scrapbooks and 7 packets. So for part A, so for 6A, we want 11 scrapbooks. So it's 11 scrapbooks, 11 times, and scrapbook is 1 1/4, so that's 1 1/4. And then we want to add to 7 packets. So that's going to be 7 times 7/8 of an inch wide. So we have to find a multiplication and then add them together. So the first thing we need to do is we need to change 1 1/4 into a mixed number. That's 5 over 4. So we have 11 times 5 over 4 plus 7 times 7/8. And then let's multiply them together. So we have here 55. 11 times 5 is 55 over 4. Plus we have 7 times 7, which is 49 over 8. And then in order for us to add them together, we need to change this fraction to multiply into by top and bottom by 2. That becomes 110 over 8. And so once we add them together, that will give us 110 plus 49, which is 159. 159 all over 8. Now, 158 goes into 159. How many times? We need to turn this back into a mixed number. I know that 8 times 20 will give me 160. And this is just one off. So it's not going to be 20. It will be 19 instead. So this will be 19 and 7 over 8. 19 and 7 over 8 inches wide in total. So that's part A. Then, using compatible whole numbers, estimate the amount. Oh, A. We were supposed to write the expression. Sorry. So this part is A. That's done. That is A only on its own. So let me just keep this part and save it for the next part. So let's continue. Sorry, I forgot to look at the question carefully. Let's move on to B first. So it says, using compatible whole numbers, estimate the amount of space needed. So the amount of space needed is we want to make sure we have enough space. So 1 1/4 inch is the same as compatible numbers. So we want to change 11 into the nearest whole number, to the nearest denominator of 1 1/4. So that would be approximately 12, because 12 is the multiple of 4. 12 times 5 over 4. And then 7, well, we have to round that to 8 times 7 over 8. So that was the question over here. So we have to round it using estimate. And then 12 can be divided by 4 easily. That becomes 3. 8 and 8 will cancel out. So we have here, our expression becomes 3 times 5 plus 7, which will result in 15 plus 7, which is 22. That's an approximate. It's not exactly the same. It's not exactly, you can see that our estimate is actually quite a little bit far off from the actual 19 and 7 over 8 over there at the bottom. But that's an estimate. Hopefully I didn't do anything wrong. Nope. And then C, is your estimate a high or low estimate? It is a high estimate because we rounded the whole numbers up. Then in part D, based on the estimate from part B, will the 11 scrapbooks and 7 packets fit on the shelf? will it fit? Well, with the high estimate, we don't know if that actually fits. Well, based on it, it shouldn't fit because 22 is way more than 18 inches. And so, based on the estimate, 22 is bigger than 18, so it wouldn't fit. Then find the actual amount. That will be E over here. Does this value compare with your estimate? Will the 11 scrapbooks and 7 packets fit on the shelf? Well, 19 and 7 over 8 inches is still greater. So we can write down 19 and 7/8 of an inch is still bigger than 18. So it would not fit. So even though we use the actual one, it still wouldn't fit. It wouldn't fit into the 18-inch shelf. So this is question 6. Question 7. The diagram shows a page from a magazine. Estimate the area first. So we want to estimate the area. So for question 7a, we want to do 10 and 13 over 16 times 8 and 1/4. Now this is not whole number times fraction. This is fraction times fraction. So for this one, what we have to do is we'll have to round both of these numbers to the nearest whole number. So that will be approximately 10 and 13 over 16 is closer to 11, and 8 and 1/4 is close to 8. So it's 11 times 8, which is approximately 88 square inches, approximately. Then it says find the actual area of the page. So let's do the actual area. So 10 and 13 over 16, we have to change that into a mixed number. 10 times 16 is 160. 160 plus 13 is 173. So that'll be 173 over 16 multiplied by 8 times 4 is 32 plus 1 is 33. 33 over 4. Oh, sorry. 33 over 4. And then in order for us to, I don't think that there are any simplifying that can be done, unfortunately. 173 seems like a prime number. And so maybe we will have to actually multiply it out together. Let's do that. So it's going to take a little bit of time, but 173 times 33, let's do that. 3 times 173 times 3 is 9. 3 times 7 is 21. 3 times 303 plus 2 is 5. 519. That'll be the same 519 at the bottom. Add them together. That's going to be 9, 10, and then that's 2 plus 5 is 7, and then that's 5. So 5,709, that's the top. So that is equal to 5709, all divided by, then we have 16 times 4 at the bottom, which will be 4 times 10 is 40. 6 times 4 is 24. Add them together. That's going to be 24 plus 40, which is 64. And then change that into a mixed number. So 64 goes into 5,709. How many times? I'm going to make a rough guess. For this one, I will allow us to maybe use a calculator. 64 times 80. Let's just try. Maybe 990 or 89, 88. So we have here, after simplifying, that becomes 88, in fact. 64 goes into that 80 times. So 5709 minus 5632. And then we have a remainder of 77 over 64. Oh, it goes into one more time. Sorry. So it should be 89 inches. 89. So 64 goes into 5,709 89 times, and then the remainder 5709 minus 5696 will be 13 over 64, and that is the actual square inches. And then how does the actual area compare with the estimate? I would say it's pretty close. It's quite close, very similar to the estimate. Now in part C, it says the width of the garden diagram is about 2/5 of the width of the page, and the length of the diagram is about 3/4 the length of the page. And then estimate the area of the diagram. So what does it mean by diagram? This is the diagram that it's talking about, the diagram. And so the width is 2/5 of the page, and then the length is 3/4 of the page. So what I'm going to do is we're going to estimate by estimating the width first. So part C will be quite complicated. We're going to do quite a lot for that. So I'm going to do it over here, part C. So first, in order for us to do the width I'm going to label width estimate will be 2/5 of the actual page, which is 8 1/4. So 2/5 times 8 1/4. And so for us to estimate, maybe this one we don't need to estimate, or maybe we can sort of estimate by let's change this. So that's 8 1/4 is 33 over 4. So let me change that into improper fraction first. 33 over 4. So I'm going to estimate by making this into compatible numbers. So I'm going to change 33 to approximately 35. And so we have 2 times 35 all over 5 times 4. And so 2 and the 4 can cancel out. That becomes 2 at the bottom. And then the 5 and the 35 and the 5 can cancel out. That becomes 7. And so it's approximately 7 over 2. That's 3.5. So that's the width, approximately 3.5. And then for the length estimate, the length will be 3/4 multiplied by 10 and 13 over 16. And so this one is very 10 and 13 over 16, we definitely are going to estimate that. But the way we're going to estimate is we're going to make the numbers compatible. And so if we remember what 10 and 13 over 16 is in the mixed numbers, that's 173 over 16. So let's change that. So that's 173. Let's move that, 173. And so we're going to change these numbers into compatible numbers to make things easier to calculate. So 173, the closest multiple of 4 to 173, I would say is 4 times 160 is compatible, 164, 68, and then 72. 172 will be the next compatible to the next multiple of 4. And then for 16, I'm going to change it into 15 because 15 and 3 can simplify. So that's approximately 3/4 times 172 over 15. Just approximating. They're very close numbers. But now 3 and the 15 can cancel out. That becomes 5 at the bottom. 172 can cancel out with 4. That becomes 13. So that's sorry, not 13. 43. So 43 does that's 4 times 43, it's 172. So we have 43 over 5 as the estimate for the length. So the overall estimate, overall estimate will be it will be 7 over 2 times 43 over 5. And then we can multiply it together and then we change it back. So 7 times 43 Or maybe we can estimate even more by making these compatible numbers as well. And I would say the best estimate that we can do is to change 43 into a even number to divide by 2. And so because that is a rather big number. So let's change 43 into 44. So that's approximately 44 over 2. So that will become 22. And so 7 times 22 over 5. Or actually, instead of doing this, I'm sorry. So estimate, we can change 43 over 5 into 45 over 5. Let's make it even easier. So that's approximately 7 over 2 times 45 over 5. I'm just changing that so that 45 over 5 becomes an easy number. That becomes 9. And so 9 times 7 over 2, 9 times 7 is 63. So 63 over 2. And so let's just change that to approximately 64 over 2, which is approximately 32 square inches. So that's just an approximation of the diagram. Now there are more than one ways to find the estimate. You don't have to use the same method as me, but make sure you do explain your steps. So don't just give me an answer, just explain all your steps. So that's the best estimate that I can, the most accurate estimate, let's just say. Moving on to question 8. You want to make half of a recipe that calls for 2¼ cups of flour, and there are 16 tablespoons in a cup. How many tablespoons more than a cup of flour do you need? Now, when we first look at this question, it may seem a little bit confusing. We don't really know what we want to do. So let's break it down into smaller steps. So first of all, let's look at the information that we know. We want to make half a recipe. Half of a recipe. So we want to make sure that is half of a recipe. And then in that recipe, it requires 2¼ cups of flour. So let's just first look at how many cups of flour we require for half a recipe. That's going to be half multiplied by 2¼ cups of flour. So this is question 8. We want half a recipe, and the recipe requires 2¼ cups. So half of 2¼ So let's change 2¼ into mixed number. That's going to be equal to half multiplied by, that's going to be 9 over 4. 2 times 4 plus 1 is 9. 9 over 4. And so 1 times 9 is 9. And then 2 times 4 is 8. So that becomes top times top, bottom times bottom. That's going to be 9 over 8. And so that changes into 1 and 1/8 into mixed number. 1 and 1/8 cups of flour for half recipe. So that's the amount of cups of flour we require for half recipe. And then it says there are 16 tablespoons in a cup. 16 tablespoons in a cup. How many tablespoons more than a cup of flour do we need? Now we already know we need 1 cup of flour. That's one cup. 1 cup. And then we also need plus 1/8 cup extra. And so what we need to do is we need to convert that 1/8 cup into tablespoons. There are 16 tablespoons in a cup, and so the amount of tablespoons we need will be 1/8 of a cup times 16, and that just turns into 2 tablespoons. So that's equal to 2 tablespoons extra, more than a cup. So that is question 8. Finished. So make sure you have marked your own work. If you had any questions wrong or any questions that you didn't understand, then rewatch that question part that I explained and try to make sure you understand afterwards. And then please post your homework, the work you've done, including marking. So I want to see you tick your own work or cross and circle the parts that you got wrong. Make sure you mark your work, take a picture of that, and then post it into the homework page. Thank you for watching, and I'll see you next lesson.